Hello everyone, I think I am audible. So today we are going to start transmission VSWR question. Okay. So today we are going to start VSWR questions. So in previous class was what we have studied? We have studied VSWR, and today what we will do? Today we will do VSWR questions. So first question is this question. This is not from VSWR, it is from reflection coefficient, but they may ask in this question. This is the previous year question. It is a very good quality question, so I will discuss in the class. What is the question? It is the question: microwave circuit consisting of lossless transmission line T1 and T2 is shown in the figure. The plot showed that the magnitude of input reflection coefficient as a function of frequency is f. The phase velocity of signal in the transmission line is 2 into 10 to the power 8 meter per second. The length of T2 is T. They are asking. So first of all, what we have is watching here, that the reflection coefficient, they have given the phase velocity, it is very important, and the reflection coefficient at 0.5 gigahertz is maximum 1, and at 1 gigahertz is minimum 0. At 1 gigahertz it is 0, 1.5 gigahertz it is 1, and 2 gigahertz it is 0, and 2.5 gigahertz it is 1. So we can see it here that the magnitude of reflection coefficient is maximum at 0.5 gigahertz and minimum at 1 gigahertz. We know that reflection coefficient will be 1 in 4 cases, that means open circuit, short circuit, or purely inductive or purely capacitive. In 4 cases the reflection magnitude of reflection coefficient is 1, but here we will see when it will happen. And the second thing is that there is so many concepts here, and second thing is that in case of matching condition the reflection coefficient is 0. So you can do by anything but considering matching condition or by considering the mismatching condition. So completely mismatching condition, you can derive the formula of length, or you can derive the formula of length for matching condition also. So this is a very good question, very good question they have asked in the GATE exam. The first point is input reflection coefficient. This one is input reflection coefficient. So what is the formula for input reflection coefficient? If I will say there is gamma 1 and the length is this one is L, so what is the input reflection coefficient? So you will say that the length of gamma is L1, I will take. So you will say the input reflection coefficient will be, gamma 1 e to the power minus j2 beta L1. And I will ask what is the magnitude of input reflection coefficient. So you will say the magnitude of input reflection coefficient is gamma 1 magnitude and gamma magnitude both are same. So the magnitude of reflection coefficient here and the magnitude of reflection coefficient here both are same. There is nothing change in the case of magnitude of reflection coefficient. So this is the magnitude of reflection coefficient in terms of frequency. So here there is no change in the magnitude of reflection coefficient. So this length is nothing, it is just simply a simple connection. There is no need to know anything about this length. Just you have to consider the characteristic impedance is 50 ohm. So we will consider for matching or mismatching condition, I will take this 50 ohm characteristic impedance, and there is nothing other than this. Then this is an open circuit. So this is an open circuit, so there is a open circuit impedance, that means ZOC, and there is a impedance here Z1. So we have impedance Z1 and we have a open circuit impedance ZOC. So we can calculate the value of Z1 first of all. So first of all we will calculate ZOC. So open circuit voltage is what? Open circuit voltage is minus JZ0 cot beta L. Yes sir, we know the formula of open circuit voltage. Then we have a 50 ohm impedance. Yes sir, we have a open circuit impedance. Yes sir, what is that? the open circuit impedance is ZOC. Yes sir. And then after I will ask what is the impedance here. So you will say the impedance here is Z1. The impedance here is Z1. There are 4 cases so that we can find out the condition for that one. So I will take ZOC and then I will ask what will happen if ZOC is inductive, if ZOC is capacitive, if ZOC is open circuit, if ZOC is short circuit. So I will take open circuit, short circuit, then the question will be solved. If I will take inductive, capacitive, then it will be elaborated question. So I will take all 4 cases and I will solve the reflection coefficient. Then after I will teach you how to find the frequency. The reflection coefficient here is gamma 1. So magnitude of reflection coefficient here is gamma 1. Okay. So first of all I will consider the ZOC is capacitive. First case is consider that ZOC is capacitive. That means minus Jx. So ZOC is capacitive minus Jx. Then what will happen for Z1? So Z1 will be 50 into ZOC is minus Jx and divided by 50 plus minus Jx. So it is not open circuit, it is not short circuit, it is not purely inductive, it is not purely capacitive. So for magnitude of gamma 1 is equal to 1, for magnitude of gamma 1 is equal to 1, there is 4 cases. There is 4 cases for Z1. What are the 4 cases for Z1? Z1 will be open circuit, Z1 will be short circuit, Z1 will be purely inductive, and Z1 will be purely capacitive. Z1 will be purely capacitive. In this case, the magnitude of reflection coefficient will be 1. So here nothing this case, nothing like this case. Z1 will be minus Jx1. So I will ask what is the value of Zin. So Zin is not open circuit, not short circuit, not it is a purely inductive, not it is a purely capacitive. So it is not our condition which we want to meet it. So first case is over. Then we have second case. ZOC I will take purely inductive. If ZOC is purely inductive, what will happen? If ZOC is purely inductive, then Z1 is equal to 50 into Jx and divide by 50 plus Jx. So what you will get? You will not get the condition at which magnitude of reflection coefficient will be 1. So in this case, magnitude of reflection coefficient will not equal to 1. In this case, magnitude of reflection coefficient will not equal to 1. In this case, magnitude of reflection coefficient will not equal to 1. Then we have third case, ZOC is equal to short circuit. That means short circuit. In this case, magnitude of reflection coefficient Z1 will be equal to 50 into 0 divided by 50 plus 0. So you will get 0. That means you will get gamma 1 is equal to 0 minus Z0, 0 plus Z0, it is equal to minus 1, which is equal to minus 1. So gamma 1 is equal to minus 1. 0 minus Z0, 0 plus Z0. So gamma 1, so it will be minus 1. So magnitude of gamma 1 is equal to 1. So this is the condition. At this condition, the magnitude of reflection coefficient is 1. So I will consider this and I will solve this. Or fourth case, I will also see. So in case of fourth, ZOC is equal to open circuit. Open circuit, that means ZOC is equal to infinite. So in parallel condition, what is Z1? What is Z1? 1 by 50 plus 1 by ZOC. This is the parallel condition. It is open circuit, so it is 0. So this ratio will become 0. and if this ratio will become 0, so Z1 will be 50 ohm. If Z1 is 50 ohm, then magnitude of reflection coefficient will be 50 minus 50 divided by 50 plus 50, it will be 0. So reflection coefficient will be 0. So what will happen here? Here, what you see here, you can see that the reflection coefficient you will see. So in case of this one, reflection coefficient is not equal to 1. In this case, reflection coefficient is equal to 1, and in this case, reflection coefficient is equal to 1. So what will happen? You can see it here. So third case, I will take ZOC is equal to open circuit, ZOC is equal to short circuit. That means JZ0 cot beta L is equal to 0. That means beta L is equal to how much? Odd multiple of pi by 2. Odd multiple of pi by 2. Beta is equal to 2 pi by lambda into L is equal to how much? Odd multiple of pi by 2. Odd multiple of pi by 2. So our length will be odd multiple of lambda by 4. Odd multiple of lambda by 4. And in this case, gamma 1 magnitude will be 1. That means frequency will be 0.5, 1.5, 2.5 and so on gigahertz. For reflection coefficient magnitude is equal to 1, the reflection coefficient magnitude is equal to 1, the reflection at this point, the frequency will be 0.5 gigahertz. So if I will take 0.5 gigahertz frequency, then what will happen? Then our lambda is equal to Vp upon F. Vp is given 2 into 10 to the power 8. 2 into 10 to the power 8. So we know the Vp 2 into 10 to the power 8 and F is 0.5 gigahertz. So it will be 2 by 5. That means it will 0.4 meter. Then I will ask, what is the minimum value of length? So minimum value of length is lambda by 4. So L minimum will be equal to lambda by 4. L minimum will be equal to lambda by 4. That means it will be 0.1 meter. That means it will be 0.1 meter. So nothing we have done. We have just find out what is the magnitude of reflection coefficient, so that the magnitude of reflection coefficient input or gamma 1 same. So magnitude of reflection coefficient, we know that. Then we are trying to find out where the reflection coefficient will be 1. So reflection coefficient will be 1 when this open circuit will behave like a short circuit. If this open circuit behaves like a short circuit, then the reflection coefficient will be 1. So this open circuit will behave like a short circuit at lambda by 4, 3 lambda by 4, 5 lambda by 4. So open circuit will behave like a short circuit at lambda by 4. So at lambda by 4, so we know the frequency, we know the phase velocity, so we know the lambda, so we can find out the length. Second, open circuit will become open circuit, that means lambda by 2. So here open circuit will become open circuit at that point. The reflection coefficient is 0, that means 1 gigahertz. So lambda by 2, so you can find out the length. So let us see fourth case. Fourth case means which we will take open circuit as a open circuit. If open circuit is infinite, then what will happen? Minus j z0 cot beta L is equal to infinite. That means beta L is equal to n pi. That means 2 pi by lambda is equal to n pi. That means L is equal to n lambda by 2. So our minimum length will be n lambda by 2. So this is our minimum length. Then we have ZOC, so Z1 is equal to, in this point, 50 ohm. If Z1 is equal to 50 ohm, then what will be the value of reflection coefficient? 50 minus 50 divided by 50 plus 50. That means magnitude of reflection coefficient will be 0. 0, that means frequency should be so frequency should be what? Frequency should be 1 gigahertz, 2 gigahertz, 3 gigahertz, dot gigahertz. So if you know the frequency, then lambda is equal to Vp upon F. Vp is equal to 2 into 10 to the power 8, and I will take 1 gigahertz, 10 to the power 9, so 0.2 meter. So our minimum length will be lambda by 2, and lambda is how much? 0.2 meter, and divide by 2, 0.1 meter. So you can find out the length easily. So what you have found out? The length will be 0.1 meter. So 0.1 meter you can find out. So it is a very good question. You have to try out this one 2-3 times. There is 2-3 question in electromagnetic wave where you can stuck, and that was in transmission line. So that 2-3 question you have to solve. This type of question is not asked in the GATE exam, so they may be asked in this GATE exam. What they will ask? The length is lambda by 4, Z0 is 50 ohm, gamma in we know that 0.3, J 30 degree, Zin and ZL we will find out. So gamma in we know that, Zin we have to find out, and ZL we have to find out. This is the point here. So first of all, what we will do, we will try to find out the ZL formula, or Zin you can easily find out. So first of all, I will try to find out ZL. So how will find out? You can find out by two methods. First of all, you will find out Zin, then you will find out ZL. First of all, you will find out ZL, then you will find out Zin. So there is a first method. This question may be asked in the GATE exam, and the calculation will be very easy. My calculation may be very tough, but that calculation will be very easy. So gamma L will be equal to, gamma in will be equal to, what is gamma in? So at a distance, gamma in e to the power minus j 2 beta L, e to the power j minus 2 beta L. So gamma in we know that 0.3, e to the power minus j 30 degree, and gamma L we know that, don't know, e to the power minus j, beta is 2 pi by lambda, and lambda it is given lambda by 4 length, so lambda by 4, e to the power j pi it will be minus 1, so 0.3, and gamma L will be 0.3 e to the power minus j pi minus j 30 degree, and gamma L e to the power j minus 180 degree. So gamma L will be equal to 0.3 e to the power minus j 150 degree plus 150 degree. So you have understand the formula how you get gamma L. So then gamma L you will get, so 0.3, 30 degree, so cos 150 degree. Cos 150 is cos 30, and cos 30 is minus root 3 by 2 plus sin 150 degree. Sin 150 degree is sin 30, and sin 30 is 1 by 2. So 0.3 minus 1 by root 3 by 2 minus root 3 by 2 plus j 1 by 2. So it will be 0.15 and minus root 3 by 2. So it will be 0.15, how much? 0.15 root 3 and 0.15 j. So you know the value of gamma L. If you know the value of gamma L, you can calculate ZL. How? Gamma L is equal to ZL minus Z0, and then ZL plus Z0. So ZL will be equal to, by applying component dividend, Z0 1 plus gamma L 1 minus gamma L. So how much it will be? It will be Z0. Z0 is how much? Z0 we know 50 ohm. So it is 50 ohm. And 1 plus gamma L. Gamma L is how much? So gamma L is minus J something. Yes sir. So 1 plus gamma L 0.15 root 3 minus J plus J 0.15 root 3. Yes sir. And 0.15. And you will calculate the value of this one. You can calculate the value of this one. So what is the value of ZL? ZL is 50. Yes sir. 1 minus 0.15 root 3. So I have to calculate this value. I have to calculate this value. .15 root 3. 1 minus answer 0.74 plus J 0.15 divided by then we have 1 plus 0.15 root 3. .26 minus J 0.15. So I will solve by the method of what? Complex number. So magnitude is how much? So 74 and 15. 74 square plus 15 square. So it will be under root 15 square. Under root answer 75.5. Okay. And 126 square plus 15 square. It will be 126.89. 126.89. Okay. Then 15 divided by 74 in degree. So we have to calculate in degree. Degree in tan inverse alt. It will be 11.45 degree. 45. And imaginary negative and real positive, fourth quadrant. Okay. So 15 divided by 126. 6.78 degree minus. So it will be 50 and the division will be, so 50 into 75.5 divided by 126.89, 29.75, 29.75 at an angle 11.45 plus 6.78, 18.23 degree. So this is the value of ZL. Then you have calculated ZL. So this is the value of ZL. 75 cot 18.23 degree and plus J 29.75 sin 18.23 degree. So you will calculate ZL. Then Zn is equal to, so at lambda by 4 Zn is equal to Z0 square upon ZL. at lambda by 4, Zn is equal to Z0 square upon ZL. Z0 we know that 50 square, and ZL we know that 29.75 at angle 18.23 degree. So 50 square 2500. So 50 square divided by 29.75, it will be 84 at angle minus 18.23 degree. So it will be 84 cos 18.23 degree and minus j 84 sin 18.23 degree in ohm. So you have calculated Zn. You have calculated Zn, but this mathematics is very complex, so we have to calculate only gamma L up to gamma L, and then after you have to understand the process. So first of all you calculate ZL by using gamma L, then you have to calculate Zn. Okay, then we have what we have. Then second thing is how you will calculate this one. How we will calculate this one? Second method, if gamma in is given, gamma in is known, you have to calculate through gamma in also. How you will calculate through gamma in? So gamma in, you know that gamma in is equal to Zin minus Z0, Zin plus Z0. Yes sir. So you know gamma in. Gamma in is how much? 0.3 cos 30 degree minus j 0.3 sin 30 degree. So this is gamma in. Zin we don't know, Z0 we know that. So Zin, yes, 1 plus Z0. So point cos 30 degree is 0.15 and 0.15. So Zin is equal to Z0 1 plus gamma in divided by 1 minus gamma in. You know the value of Z0 50. You know about the value of gamma in 0.15 root 3 and 0.15 divided by 1 plus 1 minus 0.15 root 3 and plus j 0.15. So we have calculated. So what will be the value of this one? So this one will be 0.74 and 1.26. So 50.1.26 and minus 0.15 and 0.74 plus j 0.15. So when you calculate the value, you will get the value. How much? You will get the value of this one. Zin will be equal to 84 at angle minus 18.23 degree. Then you have calculated Zin, then you can calculate ZL also. So Zin is equal to Z0 square upon ZL. So ZL is equal to, it will be Z0 square upon Zin. So Z0 we know that 50 square, or Zin we know that 84 at angle minus 18.23 degree. So you will solve, you will get 29 point something. How much you will get? 29.75, 18.23 degree. So this is the answer you will get. This is the answer you will get. So this is a very beautiful question. The question answer will be very easy calculation. But right now I have given the complex calculation. In GATE exam it will be very easy calculation. I will cross check once. Yes, 84 degree. So we have calculated these two questions. This is very good question. They have asked in the GATE exam. They will ask in the GATE exam also. Okay. Then we have what we have? We have next question. Next question. What we have? This is a very good question. When I taught transmission line, I may be asked question like this. So this is a very good question. So this question is also very good. This is a very good question. Okay. I number the question. This is third question. In this question, what they will ask? I will ask you what they will ask. First of all, they will ask what is Z in 1. So I have to calculate Z in 1. I have to calculate Z in 2. I have to calculate Z in. Then I have to calculate Z in. So first of all, what we have to calculate? We have to calculate Z in formula. So what is the formula for Z in? What is the formula for Z in? You should know that. So Z in formula should be Z in at length lambda by 4. What is the formula? Z naught square upon ZL. Z in at length lambda by 2 and lambda by 2. What will be the formula? ZL. And this is odd multiple of lambda by 4. This is odd multiple of lambda by 4. And when Zin is equal to length lambda by 8, I have taught you in the previous class. So at lambda by 8, what will be the Z naught? ZL minus ZL plus JZ naught, Z naught plus JZL. Yes, sir. And then Zin is equal to at length 3 lambda by 8. What will be the Z naught? ZL minus JZ naught divided by ZL plus JZ naught. Yes, sir. So this all four formula we will use in this question, first, second and third formula. So first formula is what? First formula is what? First formula is our, what we have first formula? Our Z in 1. So Z in 1 is equal to Z naught square upon ZL. Z naught square upon ZL1. So this is our ZL1. This is ZL2. So I have to find out Z in 1. So length is lambda by 2. So lambda by 2 length. So I will take ZL1. At lambda by 2, ZL1. ZL1 is how much? 2R0. Yes, sir. ZL1 is how much? 2R0. Then for Z in 2, length is lambda by 4. Length is lambda by 4. So it will be Z naught square upon ZL2. Z naught is R0 and ZL2 is R0 by 2. So it is 2R0. And at this point there is no transmission line. At this point there is no transmission line. So at this point we can apply network theory. So here Z in 1, Z in 2 both are parallel, and Z in is equal to parallel combination of Z in 1, Z in 2. So Z in if 3 is equal to Z in 3 is parallel combination of Z in 1 and Z in 2. Z in 1 and Z in 2 are 2R0 and 2R0. So you know how to solve 2R0, 2R0 parallel condition. That means 2R0 into R2R0 divided by 2R0 plus 2R0. So it will be R0. It will be R0. So we are applying network theory concept. After that there is a transmission line of length lambda by 8. So lambda by 8 transmission line length. So Z in. Here ZL, Z0, ZL minus JZ0, ZL plus JZ0 divided by Z0 plus JZL. So I will ask, what is the ZL for this Zin? For Zin, ZL is Zin 3. So I will put ZL is equal to Zin 3 is equal to R0. Yes. So Z0 is R0. ZL is R0 and plus JR0. So R0 plus JR0. So if I will put R0, R0 everywhere, it will be R0. So what is the value of Z in 1? 2R0. What is the value of Z in 2? 2R0. What is the value of Z in 2R0? And what is the value of Z in R0? So in this case there is a matching, because Z in 3 is R0 and this one is also R0. So there is a matching condition. This is a matching condition. Then what will happen? Then same question they will ask something else. Same question they will ask something else. What they will ask? They will ask a reflection coefficient. They will ask a reflection coefficient. So I have to give a reflection coefficient. First of all, I will write down what is Z in 1. So Z in 1 is 2R0. What is Z in 2? Z in 2 is also 2R0. What is Z in 3? Z in 3 is R0. And what is Z in 4? Z in is also R0. Then we have to find out the reflection coefficient. So at this point the reflection coefficient gamma 1. At this point the reflection coefficient is gamma 2. At this point the reflection coefficient is gamma 3. At this point the reflection coefficient is gamma 4. At this point the reflection coefficient is gamma 5. And at this point the reflection coefficient is gamma in. So we have a reflection 6 reflection coefficient, gamma 1, gamma 2, gamma 3 and gamma in. The formula is more important than the answer. So we have to know how to apply gamma reflection coefficient formula. ZL minus Z0, ZL plus Z0, ZL minus Z0, ZL plus Z0. And for Z gamma 2, Z in 1 minus Z0, Z in 1 plus Z0. Z in 2 minus Z0, Z in 2 plus Z0. So the formula is more important here. So gamma 1 is Z in 1 minus ZL1 minus Z0, ZL1 minus Z0 divided by ZL1 minus plus Z0. Yes sir. So ZL1 is how much? So ZL1 is 2R0 and Z0 is R0 divided by 2R0 plus R0. So how much it will be? It will be 1 by 3. Then there is gamma 2. In case of gamma 2, what will be the formula? So Z in 1 minus Z0, Z in 1 plus Z0. So our formula is more important here. Always try to understand. Our formula is more important here than calculation. So in this case, reflection coefficient is Z in 1 minus Z0, Z in 1 plus Z0. How much reflection coefficient is there? 2R0 minus R0, 2R0 plus R0. So the reflection coefficient will be 1 by 3. So the reflection coefficient will be 1 by 3. Then we have next case. What we have? Next case is our gamma 2. So gamma 3 is equal to ZL2 minus Z0, ZL2 plus Z0, ZL2 minus Z0, ZL2 plus Z0. ZL2 is R0 by 2 minus R0, R0 by 2 plus R0. How much it will be? Minus 1 by 3. So this is minus 1 by 3. Then gamma 4. Gamma 4 is how much? Gamma 4 is Zin minus Zin2 minus Z0, Zin2 plus Z0. So Zin2 minus Z0, Zin2 plus Z0. So it will be how much? Zin2 is how much? So Zin2 is 2R0. So 2R0 minus R0 divided by 2R0 plus R0. How much it will be? It will be 1 by 3. So gamma 3 we have calculated, gamma 4 we have calculated. So we have calculated everything, gamma 1, gamma 2, gamma 3, gamma 4. And again I will give some formula, so you can write it down. I am going to the next page. Again, then we have next formula. That what is the formula? For gamma 3, for gamma 3, gamma 2 and gamma 4, there is a formula. So gamma 2 is gamma 1 at a distance 2 beta L, and here gamma 1 is equal to 1 by 3 and L is equal to lambda by 2. L is equal to lambda by 2. Where? For this one. So gamma 1, it is traveling 2 beta L distance. So 2 beta L distance. Gamma 1, you know that. How much it will be? Sir, gamma 1 will be 1 by 3. Gamma 1 will be 1 by 3. So 1 by 3 e to the power 4 pi by lambda into lambda by 2. So how much it will be? 1 by 3 e to the power minus j2 pi. E to the power j2 pi is 1 by 3 cos 2 pi minus j sin 2 pi. So cos 2 pi is equal to 1. So it will be 1 by 3. So gamma 3 will be 1 by 3. What is the value of gamma 4? So gamma 4 in terms of gamma 3. Gamma 3, it is e to the power minus j 2 beta L, and L is equal to here lambda by 4. So gamma 3 is how much? Minus 1 by 3 e to the power minus j 4 pi by lambda, and length is lambda by 4. So it is e to the power j pi, e to the power minus j pi cos pi and sin pi, minus 1 by 3 cos pi and minus j sin pi. It will be 1 by 3. It will be 1 by 3. So this formula is important for me. This formula is important for me. Okay. This is the very, very important formula for me. Then we have gamma 5 and gamma 5. I will write down the formula also for each and every point. So gamma 5. What is gamma 5? So gamma 5 is nothing but Zin3 minus Z0, Zin3 plus Z0. Zin3 is how much? R0. So R0 minus R0 divided by R0 plus R0. So it is very, very important to calculate input impedance. Then you can calculate reflection coefficient. So gamma 5 is 0. Gamma 6 is in terms of Zin minus Z0 divided by Zin plus Z0. How much Zin? Zin is equal to R0. So R0 minus R0, R0 minus R0 divided by R0 plus R0. So it will be how much? 0. Then we can use the formula for gamma in what is the formula for gamma in? So gamma in will be gamma 5 at a distance lambda by 8. So gamma 5 at a distance lambda by 8. So 4 pi by lambda into lambda by 8. Lambda by 8 means pi by 2. Pi by 2 matlab means minus j. Pi by 2 means minus j. So it will be minus j. So it is 0. So it is 0. So reflection coefficient will be 0. So we have calculated reflection coefficient. We have calculated everything. Yes, sir. We have calculated everything. Yes, sir. Then we will calculate VSWR also. Next day we will do VSWR question discussion. Next day also we will do VSWR question discussion. Then they will ask what? They will ask VSWR. I will write everything. I will write every formula. Just I will calculate. Then after I will write every formula. And the formula is important here. So here VSWR. Here VSWR1. Here VSWR2. Yes, sir. So what is VSWR1? So you will say VSWR1 is equal to, what is VSWR1? So 1 plus mod gamma 1, reflection coefficient is 1, 1 plus mod gamma 2. And gamma 1 and gamma 2 magnitude is same. Gamma 1 and gamma 2 magnitude will be same. So we can write it down in terms of gamma 1 or in terms of gamma 2. So 1 plus 1 by 3, 1 minus 1 by 3. So it will be how much? It will be 2. So we can write the VSWR formula. Next we can write in terms of gamma 2 also. In terms of gamma 2 also. Next we can write the formula for VSWR in terms of impedance also. Impedance also. ZL1 is greater than Z0. So ZL1 upon Z0. Since ZL1 is greater than Z0. Yes, so since ZL1 is greater than Z0, so we can write down like this also. Yes, sir. So what is the value of gamma? So gamma, value of gamma is 1 by 3 and 1 minus 1 by 3. So it is 2. It is 2. Or you can calculate for this one also. For this one, what is the value of gamma? So for this one also, you can use for this one also. So what is the ZL1? ZL1 is 2R0 divided by R0. How much it will be? 2. How much it will be? 2. So it is 2. So we can calculate VSWR in terms of reflection coefficient, gamma 1 or gamma 2. VSWR in terms of impedance, we can calculate. So we can calculate impedance, reflection coefficient in terms of anyone. Yes, sir. So this is the very, very important points. You can write it down. Then we have gamma 2. Similarly, VSWR2. So VSWR2 we have gamma 3 and we have gamma 4. We have gamma 4. So in terms of gamma 4 it will be okay. So what it will be? It will be 1 plus 1 by 3 and divided by 1 plus 1 by 3. So how much it will be? It will be, how much it will be? It will be 1 plus 1 by 3, 1 minus 1 by 3, 2. It is very easy. or we can calculate VSWR2. VSWR2 is ZL2, Z0 upon ZL2. Why? Because ZL2 is less than Z0, and here ZL1 is greater than Z0. So ZL2 is less than Z0. What it will be? It will be R0 upon R0 by 2. So it will be 2. It will be 2. So VSWR2 you can calculate. Then you can calculate VSWR. This is question number 5. They are asking what? They are asking VSWR. This is question number 5. Question number 6. We have. What we have? Question number 6. So question number 6. Sorry, question number 5 is only. So then we have VSWR. So VSWR will be equal to Z in 3 upon Z0. It is R0. So for equal the VSWR, impedance matching, VSWR is equal to 1. Or you can use VSWR is equal to 1 plus gamma 5, 1 minus gamma 5. Or second one is 1 plus gamma 6 and 1 minus gamma 6, gamma in. So 1 plus 0, 1 minus 0. It is 1. Matching condition 1. Then I will write what are the all formula you have studied till now. It is very, very important. So what are the all formulas you have studied till now? So I will write it down. I am making this diagram something smaller so that I will write down in a single page. So we have, first of all, we have Z in 1. What is the formula for Z in 1? Z in 1 is Z0 square upon ZL1. Second, we have Z in 2. Z in 2 is Z0 square upon ZL2. Z0 square upon ZL2. Then we have Z in 3. Z in 3 is Z0 parallel, Z in 1 parallel Z in 2. This is parallel condition. Then we have fourth, Z in. Z in is nothing but Z0, Z in 3 plus JZ0 divided by Z0 plus JZ in 3. Why? Length is lambda by 3. Length is lambda by 8. For lambda by 2, same impedance. Lambda by 4, Z0 square upon ZL. Or for lambda by 8, Z0, ZL plus JZ0, Z0 plus JZL. Like that. Then fifth one, I have used the formula for gamma 1. Gamma 1 is nothing but ZL1 minus Z0, ZL1 plus Z0. And then we have gamma 3. Gamma 3 is nothing but ZL2 minus Z0, ZL2 plus Z0. ZL2 minus Z0, ZL2 plus Z0. So we have gamma 3. Then we have gamma 2. Gamma 2 is Z in 1 minus Z0, Z in 1 plus Z0. Z in 1 minus Z0, Z in 1 plus Z0. and then we have gamma 4, Z in 2 minus Z naught, Z in 2 plus Z naught, Z in 2 minus Z naught divided by Z in 2 plus Z naught. Then we have gamma L. We have gamma L. What is gamma L? Gamma L means reflection coefficient. So what is gamma 2? So gamma 2 in terms of gamma 1. Gamma 1 e to the power minus j beta L. So I will write it down in the next page. So this is the formula for a reflection coefficient. There is so many other formulas also. So you have to apply some mind, then you will analyze this formula. Then you will analyze this formula. 9. Ninth one is gamma 2, gamma 5. Gamma 5 is Z in 3 minus Z naught, Z in 3 plus Z naught. Z in 3 minus Z naught, Z in 3 plus Z naught. Next, then we have gamma n. Gamma n is Z in minus Z naught, Z in plus Z naught. Z in minus Z naught, Z in plus Z naught. Then we have reflection coefficient gamma 1. Gamma 2 in terms of gamma 1. Gamma 1 e to the power. Gamma 1 e to the power minus j 2 beta and length is lambda by 2. Length is lambda by 2. Lambda by 2 length, so lambda by 2. Then we have gamma 4. Gamma 4 will be gamma 3 e to the power minus j 2 beta. Length is lambda by 4. Yes, sir. Then we have gamma 4. Then we have gamma 5. Gamma 5 we have calculated gamma in. Gamma 5 e to the power minus j 2 beta. Length is lambda by 8. Then we have calculated VSWR. VSWR 1 is ZL 1 upon Z naught, and VSWR 2 will be because ZL1 is greater than Z naught. VSWR 2 will be, so VSWR 2 will be, it will be ZL2 Z naught upon ZL2. Z naught upon ZL2. Why? Because ZL2 is less than Z naught. ZL2 is less than Z naught. ZL1 is greater than Z naught. So this is the formula for VSWR. Then we have what we have? VSWR formula in terms of reflection coefficient. VSWR formula in terms of reflection coefficient. So 16. VSWR 1. What is the reflection coefficient? 1 plus mod gamma 1. 1 minus mod gamma 1. And 1 plus mod gamma 2. 1 minus mod gamma 2. Yes, sir. So this is 1 plus mod gamma 1, 1 minus mod gamma 1. Or you can apply here also, because VSWR does not depends upon distance in lossless transmission line. In lossy transmission line depends, but in lossless transmission line it does not depends. So gamma 1, or in terms of gamma 2 you can write. Again you have VSWR what? 2. So it will be 1 plus mod gamma 1, how much? Gamma 3, and 1 minus mod gamma 3, or 1 plus mod gamma 4, 1 minus mod gamma 4. In lossless transmission line, VSWR does not depends upon distance. In lossy it depends. Always remember. So VSWR will be in terms of Z in 3 minus Z naught. VSWR will be 1 plus gamma 5 and 1 minus mod gamma 5. Yes, sir. So this is the condition for VSWR. This is the condition for VSWR. So we have studied so many things. Just summarize this thing. Do this problem, this question 1 times, 2 times, 3 times, so that you will understand this problem. If you are not doing this problem 1 times, 2 times, 3 times, then you will not understand this problem. Then you are not going to understand this problem. So if you want to understand this problem, you have to do this problem 2-3 times. All 3 questions. All 3 questions you have to do 2-3 times. This one is the 5 question, and then after 2 questions. So all 5 questions you have to do so many times, so that it will be not over. Then this is the question, homework, self-assessment. You can do it by self. You can do it yourself. I will discuss in the tomorrow class question number 6. So tomorrow class I will discuss 10 to 15 problems, because that problem is very easy, and this is, you can understand, this is not a single problem. 1 problem, 2 problem, 3 problem, 3 VSWR question, 3 question. Reflection coefficient, they have 6 question. Impedance, they have 3 question. So there is 12 questions, and so many other things are there. So you have to understand this question, and we will follow that question. Okay, so this is our self-assessment question. Then what we have done today, we have done VSWR questions. Yes, sir. Today we have done VSWR questions, and you can download this Unity app. It is important. This one you can now download, and you will get benefited by this. And second thing is, you can join this Telegram channel, Sonu Sir PW, and you will solve any doubt. I will solve your any doubt in this channel. You can ask me anything. Thank you everyone. We will meet it again in the next class. Thank you.